Alright, on to the next problem. A race car travels on a track at 44 meters per second and slows at a constant rate of velocity of 22 meters per second over 11 seconds. How far does it move during this time? Okay, so one more time. A race car travels on a track at 44 meters per second and slows at a constant rate of velocity. And this is probably, it slows at a constant rate of velocity to 22 meters per second over 11 seconds of time. How far does it move during this time? Okay, so we have a track, we have a race car, and we're going to say that our race car is going in the positive x direction. We'll say where it's starting, where we start tracking it when it's going 44 meters per second. That's going to be our initial. That's going to be our origin, our 0, 0. So we drew a picture. We established our origin. Now let's list our knowns and our unknowns. Now this is a list of knowns and unknowns that I fall back on to really often. It's usually a good setup when we're looking at these motion problems. So we're always kind of saying, what's my initial position? What's my final position? And then we're also wondering what's my initial velocity and what's my final velocity. And then we're also looking for acceleration and time. Okay, so those are the ones that we kind of always go back to. Now, in this situation, I've established my origin of this starting point when we start tracking them at this 40 meters per second. So my initial position is 0. Okay, 0 meters. And then my final position, that's what I'm solving for. How far does it move during this time frame? Well, that's what I want to know, my final position. My velocity initial is 44 meters per second. And my final velocity is 22 meters per second. I'm not sure what my acceleration is, but I know that this occurs over 11 seconds. So we need to find an equation that does not contain an acceleration component because we don't know that. We could solve for it if we need to, but let's see if there's an equation we can use where we don't have to calculate that. So we want x final with no acceleration. Okay. So acceleration component. That's my average velocity. These lines here, they denote average. So this is average velocity, average velocity. And so, yeah, let's I guess take a step back and let's solve for this acceleration that's occurring. So acceleration is a change in velocity over a change in time. And we know that delta V is V final minus V initial, and T final minus T initial, but our initial time is just 0. Okay, so our acceleration is velocity final, which is 22 meters per second, and then minus velocity initial, which is 44 meters per second. That's going to occur over 11 seconds. Okay, so it's 22 minus 44. Negative 22 meters per second divided by 11 seconds. So my acceleration is equal to negative 2.0 meters per second squared. Okay, so we have all these components now and we want to solve for x final here. So we have this one we could use. My velocity is not average, it's not continuous, so I don't want to use that one. And then we have a delta here, but I think we're going to come back to this equation. Okay, so x final is equal to x initial plus velocity initial times by t plus 1/2 times by acceleration times by t squared. Okay, x initial is 0. X final is what we're solving for. Velocities, accelerations. Okay, so let's do unit analysis. Let's see if we do end up with meters here. Okay, so we're taking velocity, which is meters per second, and we're multiplying that by seconds. Okay, so those are going to cancel and we'll be left with meters. And we're adding that to 1/2, which is unitless acceleration, which is meters per second squared, times by time, which is in seconds, but that's squared as well. So those seconds cancels. So we're left with meters plus meters does in fact equal meters. Okay, so good. Our rearrangement and choosing our equation, that was done correctly. Now let's plug in our numbers. So x final is equal to velocity initial, which is our 44 meters per second, times by time, which is 11 seconds, plus 1/2 times by our acceleration, which is negative 2.0, times by time, 11 seconds, and that's going to be squared. So here we have 484, and so we had 2 sig figs, 2 sig figs. We're not going to round halfway through, but we're just going to recognize that we have 2 significant figures there, plus 1/2 times by my acceleration times by 11 seconds, that's squared. So that's going to be plus a negative 121. And again, 2 sig figs, 2 sig figs. Okay, but now we're adding these numbers. So it's going to be digits after the decimal place. We don't have any digits, and we don't have any digits after the decimal place. And so we're going to take our 484 minus the 121, and we get 363 meters. All right, keep going.